Here we have a simulation of an electromagnet, and it consists basically of a voltage source and an inductor coil. I have another video with a nail going through the core, but in this case, in this example, this is called an air core. So here's a display of the magnetic field, which is very similar to the bar magnet shown here. You can see the magnetic field in both cases have very similar properties. Now here's the North Pole, and here's the South Pole. And if I use a compass, you could see the behavior as I go around in this field. There's movement on the compass as shown. Alright, so here, this is the North Pole, and we can see the south end of the compass is attracted to the North Pole of this electromagnet. If I go to the other side, you could see that the north end of the compass is attracted to the South Pole. Now, when I flip the polarity, reversing the voltage, here, you could see that the North Pole appears here and the South Pole appears here. So reverse, and you can see the compass moved as well. Now let me use the field meter, and I'll put the field meter around here and show you that it does change. So putting the field meter here, mostly it's dominated. You can see it, the vector direction of this field is here, where this is going toward north, and that there's very little Y component as shown in this field meter, and that the field strength is dominated by the X component. Again, it's the square root of the sum of the squares between the X component and the Y component. And you can see that the angle direction is almost horizontal, and if I play around right here a little bit, I can get it toward near zero. Now, as I change the number of loops in this inductor coil, we see that the electromagnet is an application of how an inductor is used. So let me change the number of coils. Let me increase it to 4, and we should see an increase in the field strength, and we see it here. And then as I reduce it, the decrease in the magnetic field is shown here, from 4 to 3, now here from 3 to 2, and from 2 to 1. Hopefully you could see the application of an inductor is you can create an electromagnet using a voltage source and coil. Now notice I can also use an AC source, and you see the AC source means that the current goes in both directions. You can see that the magnetic field is flipping this compass needle. Now in this AC current supply, I can change the strength by moving the amplitude. I have a video discussing this sinusoidal signal we have here, and then I can also increase the frequency. So we see that an AC source creates a changing magnetic field, while a DC source creates a stationary field. So this is how an inductor is used to create an electromagnet.